So I'm not gonna really assign homework on this on 3.2. Just focus on 3.1. Looking over notes is though always a good thing. Okay, perfect squares, perfect cubes, and their roots. Any whole number that is a product of a whole number squared is called a perfect square. And the reason why I'm going to write out a number of perfect squares is because if you can memorize them or at least become very familiar with them, it's going to make your journey a lot easier, right? So 1 squared is going to be equal to 1, obviously. So 1 is considered a perfect square. Therefore, the square root of 1 is going to be equal to 1. 2 squared is equal to 4. Therefore, the square root of 4 is equal to 2. Three squared is equal to 9. 4 squared is equal to 16. 5 squared is equal to 25. Those are probably ones that you're very familiar with. 6 squared, 7 squared is equal to 49. 8 squared is equal to 64, and so forth. So this column here, which I will clearly identify later, are called perfect squares. Because if you were to take the square root of them, you get a whole number. Right? So taking the square root of a perfect square will result in a whole number, and that's what we're after here. So we're taking the square roots of those perfect squares and getting a whole number, as you can already tell. Okay, and I'm going to have another list on the right side of that. And again, this is for you to see the perfect square. So 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144. So these are the ones you need to maybe review or be familiar with, because if you identify it's like, aha, this is a perfect square, it's going to be a lot easier for you. Okay, 13 squared is 169, 14 squared is 196. Some students mix them up, like the 13 squared is 169, 14 squared is 196. Notice that the 9 and the 6 are flipped. That might help you memorizing it, right? Because you know that this one is bigger than 13 squared. And I think I will spare you, maybe I'll do 1 square root here and spare you the rest, right? Like that. We all know that if you take the square root of a perfect square, you're going to get the whole number that you started off with, right? Maybe we'll do the last one here. Square root of 225 is equal to 15. And it's these numbers here that I'm identifying down here with arrows, right? Those are perfect squares. Perfect squares, I want you to connect that. So you're thinking perfect squares, if you take the side of a square, right, and you square it, you get the area. So I want you to connect perfect squares with the area of something, right? Because technically, if the area of a square is 64, if you take the square root of it, you know that the side length of that square will be 8. Okay, so I want you to connect the two. And now we're going to do cube root. Very similar. Any number. I should say whole number. Sorry about that. Whole numbers. That is a product of a whole number cubed is called a perfect cube. So I'm going to give you a couple. 1 cubed is just 1. Therefore, and this is, I think I need to say this because it happens a lot. Students forget to say, you know, if they're trying to find the cube root of something, they forget to put the 3 in the root. If you forget that, you're technically taking the square root of a number, and that's not correct. Okay. 2 cubed is 2 times 2 times 2, which is 8. Therefore, the cube root of 8 is going to be 2. 3 cubed is 3 times 3, which is 9, times another 3 is 27. Therefore, the cube root of 27 is equal to 3. 4 cubed, and these are the ones that, right, you should look at enough times to recognize that's 4 times 4, which is 16, times another 4 is 64. Therefore, the cube root of 64 is 4. 5 cubed is 5 times 5, which is 25, times another 5 is 125. Therefore, cube root of 125 would be 5. Okay, and that's, I'm going to leave it at that. All of these numbers here are perfect cubes. Okay, so we have perfect squares up there, and then now we have perfect cubes. So you should recognize, yep, I can definitely take the cube root of 125. And I want you to relate cubes to volume, because the volume of a cube is the side length to the power of 3. So that goes both ways. The volume is side cubed, but to find the side, you would take the cube root of the volume. So let's try to make a cube here. Okay. Side, 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 right? Versus up here, area is just flat, right? All sides are the same. So this is side and side there. And that's it for this. I just wanted to have this done and over.